Hi, everyone. I'm Nitzan Shapira from Epsagon, and I'm going to talk about serverless and distributed systems and distributed tracing in such systems. So a little bit about me. I'm a software engineer. In the last 12 years, I've been doing different things from mostly around cybersecurity, stuff like reverse engineering, networking, embedded systems, a lot of infrastructure-related things. In the last year and a half, I'm one of the founders and the CEO of Epsagon. So we are a company that is helping people adopt serverless, helping them understand what's going on in their production, troubleshoot, monitor, understand cost, and so on. And I'm from Tel Aviv in Israel. So the things we're going to talk about are, first of all, we'll start with serverless. So usually I'm giving these talks in serverless conferences, so the people are familiar with it, but I'm going to give a bit more introduction about what I think serverless is. It's more than just function as a service. It's actually going to be connected to the things you talk about in this conference all the time, like containers and so on. It's more about what serverless is, as a concept is. And then we're going to talk about observability for serverless. So what do you really want to know? What is important to know? How do you do it? How is it different than what you are doing for containers, for example? And from there, we'll go into distributed tracing as one of the main tools and technologies that can help you really understand these kind of complicated systems. And hopefully, my hope is that you can take some of it to your day-to-day job and start experimenting with serverless in your work and see what you can achieve with it and hopefully develop much, much faster. So let's start with serverless. So serverless is not really a word, as you know. It's more of a buzzword that everyone tries to give different meaning for. So the way I see serverless is very different than just function as a service. Serverless is a concept that enables you to focus more on your business logic without managing infrastructure, and this way iterate faster and ship software faster and be more efficient. And function as a service is one part, so it's one way to bring your code and configure it and let someone run it for you. Usually it's going to be a cloud provider. And then you can see today services that are container as a service. So you can bring a container in a similar way without knowing even what host it's running on. So this is the way you can bring your code to the serverless vendor. And then you use managed services. So these can be databases, storage, APIs, events, and triggers that connect it all together to create a serverless application, which is where you really get the benefit of serverless, and you can run a completely serverless application and focus more on your business logic. And as you know, serverless today is mostly happening in the cloud, and AWS specifically is the most popular vendor. So AWS has Lambda, but Azure, Google, IBM, Oracle, they all have their own services around that, including independent vendors like Binaris, for example. They are sponsoring here and have their own function as a service platform that is supposed to be much, much faster. But then you can see, of course, open source projects like Knative and FaaS that you can also install on-premise or you can install in the cloud. And they supposed to give you the same experience with serverless and the best developer experience. In my opinion, serverless is actually mostly happening in the cloud because that's where you can actually scale with no limitations, and you actually can pay per use. So I'm going to focus mostly in this talk, in the examples are going to be mostly from AWS because this is the most popular service for serverless people use today. So apologies in advance. But it's actually the same things that can be applied to any cloud provider or any serverless framework. So the benefits of serverless, first of all, the financial benefits. Pay per use, it's very simple to understand. It makes a lot of sense because if you look at the right side, this is the utilization of a server in a company. So usually there are peaks, so the servers have to be much more powerful than the average usage. So in many companies, the utilization is 10 to 20%. So basically 80 to 90% they pay is for nothing. So if you just pay for what you use, you can save a lot of money, and it makes a lot of sense. You can also be in kind of a risk. I'm going to go into it later because you don't know how much you're going to pay. But if you do it right, you can actually save a lot of money. But in my opinion, the most important benefits are actually the auto-scaling and what we call low ops, which eventually lead to increased developer velocity. So developers will be able to ship software faster and iterate faster, and the whole organization is going to be more efficient. And I'm hearing today companies even very traditional enterprises that say we want to be fully serverless in X years. Every new application we do now in the cloud is going to be serverless, and so on. So companies really like this idea. So it sounds all good. If you could run it, it will be amazing. I mean, you would enjoy many, many benefits. But there are limitations. So those functions, they are limited because, by design, they are limited because they need to do those complicated things and scale. So they have limited resources. Memory running time is limited. And basically, you have a very strong incentive to choose lower memory because then you will pay less. So then how do you know that your function will not get a timeout? And the running time as well. They can run up to, in AWS Lambda, it was 5 minutes. Now they increased it to 15 minutes. Still, it's limited. And you get the fact that it's stateless. So it's good. It's by design. But now you have to think about how do you design stateless applications? Where do you put the state? It should be in a database, storage, and so on. And how do you fix problems when there is no server to connect to? How are you supposed to install something that will give you an idea what's going on? So that's another challenge. And then you get cold starts, you got concurrency limits. These things are improving over time, but you have to be aware of them when you work in serverless. But eventually, if you do it right, you can really enjoy it and run serverless in production in very high scale, in very low cost. And companies are doing it today, including us. And the main properties for serverless applications is, first of all, it is a microservices design pattern. You basically take small components and you connect them together. The main difference is that it's, first of all, it's event-driven, so it's not just functions calling to each other. It can be events that trigger the function. So for example, in the right side, you can see API gateway triggers the Lambda, puts a file into a storage, triggers another Lambda. So suddenly you have those underlying elements that trigger your code that are not part of your own code. So this is what we mean by event-driven architecture. And it's also very distributed because every function is limited. So you kind of have to spread it into smaller pieces, and then you get those highly distributed applications. And also you are very encouraged to use APIs such as Twilio, Stripe, Auth0. All of them can be used and will give you more benefit because you don't really want to do something that's already out there, and your functions are limited. So you really want to focus on your business logic. So this is the properties. And just an example from the reInvent conference 2 weeks ago, a real application from HSBC, which is a company you all know, that's running in production. So it's not just something that people play with. People are actually running these things in production. And let's talk about the challenges and why do they exist. So this is an example by Jan Kui, who is one of the popular bloggers in serverless, and he actually took a monolithic application in the company he worked for and migrated it into a fully serverless application. And take a look how it looks before and after. So obviously, this is just the design he had on paper, and then he had to deploy it. But the main problem, the main challenge in serverless applications is just the complexity. From a software design perspective, they are just more complicated. You have many more elements. You have events. You have distributed events. So how are you going to understand what's going on there? So think about taking this thing, deploying it to the cloud or to any serverless framework. How do you know what's going on? How do you know if it's working? Are you really going to look at functions and their logs? And is it going to be enough for you? How do you know the performance for the end user, the experience that he's getting? What about cost? What are you paying for? How is it split across the different services? These are questions that are very difficult to understand once this thing is in production. And the community actually agrees. The last 2 surveys, this year and the previous one, show that debugging and monitoring are the biggest challenges. And it's actually not getting any better because the applications just become more complicated. And the basic tools just are not suitable for this kind of applications. So let's go into observability and see how it applies into serverless and what we can do about it. Sorry. So in general, it's not different in serverless. If you have an application, you want to be able to do the same things. First of all, you want to know if it's working. So that's a tough question, what working means. Is it 0 errors? Is it 99% success? Is it below 100 milliseconds latency? Is it $1,000 total cost? What is the good health? So that's the one question that you want to answer. And you want to be alerted if something goes wrong. And then you want to be able to spot problems, hopefully as soon as possible, and then fix them quickly so your customers get the best experience. And finally, you want visibility into what's going on so you can make decisions for optimization of the performance. And also in serverless, it will also optimize the cost because you pay per use. So these things are eventually what you want to have. Now let's see how they apply in serverless and what can you do to get them. So if you want to know if your system is working, what can you ask yourself? So first of all, most people think of serverless as functions. OK, I have 50 functions. I deployed them. It's my code. Let's see how my functions are doing. So is this enough? So basically, it makes a lot of sense. Just look at the function metrics, see the errors, the failures, make sure it's working. So first of all, functions are important, and identifying errors, timeouts out of memories, cold starts are very useful to easily find problems in your applications. So just by measuring those metrics, you will be able to spot problems easily. But if you think about this kind of application, is it really just the functions? Is it enough for you to look at the function metrics and really understand the entire story? Because you can see that a request comes in, triggers multiple functions, APIs, events, external APIs. Maybe you get timeouts. How do you really know that it's working? It's not just the functions. And it's actually functions, but in addition, APIs, events, triggers, and what we call transactions. So a transaction would be an event that starts, triggers multiple things on the way, and ends, which is directly related to the customer interaction with the system. So this would be a better way to understand the system and to tell the entire story. And if you think about troubleshooting, so think about if you had an error in one of the functions, now you need to find out what happened, but there were 5 functions that came before, and they all communicated with each other, passed data to each other. So just by looking at logs and logs and logs, this is not the right tool to troubleshoot a distributed system. And I think people today already know that distributed systems cannot really be understood well just by using logs. This is why distributed tracing came up. So eventually in serverless, the thing is that the events are asynchronous. So you have many asynchronous invocations and events, and you need to somehow connect them together to create a distributed trace. And what we call a transaction, just an abstraction, will look something like that. It came from request, goes all the way through multiple events. And let's take an example. So if we have this application, what eventually we want is to say, OK, we had a function, but it actually emitted an event and triggered another function, and these are all connected, so we can trace back and see exactly what happened. And the second thing is to be able to go outside my cloud provider's domain and go to external APIs such as Auth0, even another cloud provider, or even from on-premise to the cloud, or vice versa. Tracing these APIs is very important in serverless, more than it is in containers, because first of all, every API call you make can cause your function to time out. Depends on your running time limit. Second, you pay. Every time you make a call, you pay for the time. So it's even more important than before to measure those API calls. So now we are going into distributed tracing. So essentially, there have been a few talks in this conference about distributed tracing, and I think the whole observability world today for microservices is going towards distributed tracing, because this is how systems are built today. New systems are usually built as microservices. And the point in distributed tracing is to be able to tell the story of a trace that comes into the system, goes through multiple services, either via direct communication or by emitting events to an underlying infrastructure. And eventually, this trace goes on and on and on until it finishes, and this is really what happened in your system from a business perspective. And when you try to troubleshoot something that happened, distributed tracing will really give you a much better sense of what happened. And when you aggregate this data over time, you will get a much better information about how your system is performing, and not just simple metrics of functions or CPU of the host and so on. So this is the point in distributed tracing. And for example, Yager is a very popular tool for visualization of the tracing data. So if you have the tracing data, the tracing spans, you can put it into Yager, and then you will see those waterfall charts. You will see how much time everything takes. And it's very easy to understand where the bottleneck is, for example. But how do you get this data? So if you have it, you can put it in this kind of tool, for example. How do you connect the dots together? That's actually the tough problem. So distributed tracing can go different ways. One of the popular frameworks that, of course, it's part of the CNCF, it's open tracing. There is also OpenCensus. And these frameworks enable you to create traces, to build trace spans. And by implementing them in your code, you can get those results, which are pretty nice, and then use something like Yager to see them. And this is a very good approach, and companies put a lot of effort in implementing these things in their system, in their microservices, and eventually they get great results. Now, the problem with this approach is that it's not really a problem, it's just the reality that it's manual. You have to put a lot of effort, you have to learn, you have to implement, you have to maintain, and eventually you're going to spend a significant amount of your developers and engineers and architects and DevOps time maintaining this thing and writing new things this way. Sometimes you don't have a choice, so that's what you do. But again, let's talk about some other options, because in serverless, you have a different world. It's not completely generic. You live inside the world of the serverless framework you work in. So you can live inside AWS, you can live inside Knative. But it's not completely generic, so you can actually do some things differently. So think about manual. Does it really make sense for serverless? If you had to go into every one of those functions and implement something manually, you have thousands of them. If you had 50 containers and microservices, maybe now you have 5,000 nodes in the graph. So does it really make sense? I mean, the whole point of going serverless is to work fast and to iterate faster, developer velocity. So if you say, OK, it's really cool, but stop, you have to do this instrumentation and manually, and it kind of misses the point in a way. You're going to spend a lot of your time doing these things just to get observability. The question is, if we can do it differently, it will be a great success, because then we'll have both the visibility and the observability, and you can work in serverless fast as you wish. So this is where automation comes in. So I'm a big believer in automation in all aspects, from testing to deploying to observability and tracing. And generally, the entire point of microservices and the cloud and Kubernetes is to iterate fast. So if you can do things automatically, you can benefit much more and eventually just go faster. So what we do in the company is we do distributed tracing for serverless automatically. So I'm not going to go inside how, but the point is that once you have it automatically, you can just go and deploy and then understand what's going on. And I'm going to give you an example of distributed tracing in serverless. So let's say you had this simple transaction. It's simple, but it's actually not that simple to understand if something goes wrong, because you have a function that is triggered by an API gateway, so HTTP request comes in. You have another function triggered by an SNS. So the first function publishes a message to the SNS and triggers the second function, and there is also authentication there before. And then the second function failed. So now you want to understand what happened. So if you just go to the logs, you can see what happened in the function, but how do you go back one step before to the other function and connect the dots? Maybe they are running a billion times a day, and how do you match the logs? Sometimes it's just not possible. So with distributed tracing, what we would want to have is something like, OK, show me the problem in this function. So this is a zero division error, like any good example. And then you can take a look at the function, see what happened there. And then the next step will be to go to the SNS and see, OK, what was the message? So you can go back and see the input. And one step further will show you the log of that function automatically. So you can say, OK, the authentication failed, so this is actually the problem. And looking at the API code, we show you that indeed it failed. And then an API gateway will tell you what was the HTTP request, the header, and the body. So this kind of tracing can solve a problem in minutes instead of hours or even days. So this is very different than just looking at functions individually. This approach is much more generic and suitable for serverless applications. And we talked about some of the challenges in serverless and how to monitor these systems. And I'm going to talk about something that is, it may sound unrelated, but I'm going to show you how it is related, which is cost. So in serverless, time is money. Pay-per-use means for every 100 milliseconds, your code is running. You are paying a very small amount, but it can be a very big amount as well. And it's a simple formula, just multiply it, which makes you really want to optimize your performance, because then you will also save a lot of money. And if you want to identify bottleneck, maybe you will also identify what's causing your application to be 10x more expensive than you expect it to be. So if you want to go and optimize the performance and the cost, you should ask yourself, where do you spend most of your time? Is it on my own code, or is it on the API calls that I'm making? That's why it's so important to trace those APIs. And I'm going to give you an example that happened to us in the company. So we are also serverless. We have about 400 functions in production in pretty high scale compared to a company our size. And we are using our own solution to monitor our system. And one day, this was about 5 months ago, I took a look at the system and saw that we have one function that the estimated cost for the month was about $15,000, one function. We are a startup company. It's not the best way to spend all the money in the beginning. So I messaged my partner, my CTO. I was sure it's a bug or something, obviously. So I said, is this for real? And then he took a look and said, yeah, it was real. We had a function that something really bad happened with it. So I was like this. And then we looked into it, and it actually enabled us to find one of the more complicated architecture problem and that caused a big performance problem in our system. So this is how cost can really help you understand what happened. And the way it happened, just on the, I'm going to go quick. We had something that connects to the API of CloudWatch and gets logs all the time. It was good in the beginning, but it was very not scalable. So every function that our customer has, we would span another function that will call the logs. And after some time, we just called the API of CloudWatch too many times, and it didn't work anymore. It just responded too slowly, and those functions started to time out. So we had 5,000 functions timing out all the time, 5 minutes, forever. So this is expensive, apparently, if you do the math. So the way we found it is actually by looking at the cost metrics. And eventually, measuring those API calls will actually help us identify it much quicker. So that's another way. So to understand how a serverless system works, it's very helpful to look at the cost. And another example about external API, just a simple example with Auth0 and Twilio. If I just make a quick look on the Auth0 here, I can see that it's much, much slower than the rest of the API calls, not because of Auth0. We are using Auth0. It's a great service, but because it wasn't configured properly. So now you have this API call all the time, and you're paying for it, and also it may cause your function to time out. Again, you have to make sure that every API call you use is in place so you can actually scale without worry about anything. OK, now, if you think about visibility and really understanding your system, so function metrics is a good way, cost is another way. But eventually, the application has certain business flows. Maybe a user subscribes to your service, a user transfers a payment via the website, and so on. And each one of these user interfacing operations will create a series of events, which you can call them business flows. And if you know that they look like this or like that, you can actually know how your application behaves on a much more business-oriented way. So it's not just you have 10 functions or 1,000 functions, but you have 10 different flows. One of them happens 90% of the time, and it's not so important. The other one is very important. I want to make sure it's fast. I want to make sure that's where I spend most of my money, because I don't want to spend most of my money on something that doesn't really help my company. And again, understanding these business flows can really help make decisions about optimization of performance and costs. And then you can say, OK, I want to focus on this business flow and go inside and see exactly what element is the slow spot and what can I do about it. Is it changing my code? Is it increasing the function memory? Is it changing to a different API? And so on. So just to conclude, first of all, I think serverless is awesome. I mean, we are using it not because we have to, because we want to. And once you start, you kind of get addicted to it, because you can really deploy much, much faster. And companies are using serverless today to build software faster. Everyone is doing it, including your competitors, probably. So I would recommend at least trying it. And if you want to understand the system, you have to remember sometimes taking the old approach, what works for a server, and applying it into a function just doesn't work. So this is where distributed tracing and other new technologies come into hand. And the last thing is automation. So always think about automation when you go into these new technologies, because you want to use them the right way, and you want to save time. So that's all. Thank you. Feel free to email me, message me, talk to me.